Hello students, welcome you all in this next video. I am solving model question paper 3 for the year 2025-26 and I am going to solve 4 marks question from part A physics. So 1 mark question, 2 mark question, 3 marks question all I have already solved and I have uploaded those all the videos on my channel. Visit my channel, watch my videos. If you like my videos, share these all the videos with your friends and please consider subscribing my channel. So let's start with first question of 4 mark from part A physics. So it is Roman number 5. Answer the following question. We have to answer 2 questions and each question will carry 4 marks. Total marks from this section we are going to get 8. So we'll start with question number 11 where you have an internal choice. Here in the first question we have A, B and C and there is another OR question. So first you have to read the question, understand which will be easy for you and then start solving in the exams. So now we will start with question number 11, first one, that is A. What is reflection of light? So we have to define what is reflection process. So the answer is, you can see, reflection of light is the phenomena or the process in which light rays bounce back into the same medium after striking a surface. So whenever the light strikes on a shining surface, it bounces back into the same medium. Such type of process it is called as reflection. For example, if you want, I can show you with the help of diagrams. So see, if this is the shining surface and if this is the shining surface of this medium, see here, and on this shining surface if the light strikes, so this is the point of incident, and on this if the light strikes like this, so this is the incident ray. This is the arrow which is showing that light is incidenting on this point which is called as point of incident, and once it strikes it reflects back into the same medium. You can see here this light ray is not passing this medium, it is getting reflected, bouncing back into the same medium, and such type of phenomena it is called as reflection of light. So this ray is called incident ray and this ray is called as reflected ray. So this is the answer for A. Now we will see B. State the laws of reflection of light. So very simple, we have to write the laws of reflection. There are 2 laws in this, so we will see both. First one, the angle of incidence is equal to the angle of reflection. See here, the angle of incidence is always equal to the angle of reflection. Now what is this angle of incidence? So we will use this earlier diagram. This is the point of incidence. On this point we will draw a perpendicular line like this. See here. Then this line it is called as normal. The perpendicular line is called as normal. The line which is incident like this, it is called as incident ray. See here. It is incident ray. And the line which is bouncing back into the same medium, this line is called as reflected ray. So I'll write it here, reflected ray. And this is normal, and this point it is called as point of incidence. Point of incidence. In this case, once the light strikes on the point of incidence, the angle between the incident ray and the normal, this angle is called as angle of incidence, denoted by the letter I. And the angle between normal and reflected ray is called as angle of reflection, that is R. So these both the angles will be always equal. Remember, these both the angles will be always equal. Angle I will be equal to always angle R. If this angle is 30, then this angle will be 30 degree. If it is 60, this will be 60 degree. For example, if this is normal and if your ray comes like this by making here 30-degree angle, then the reflected ray will also make 30-degree angle. If it is doing preparing a 60 degree, if it is coming with 60-degree angle, this also will reflect with 60-degree angle. So both the angle will be always equal. This is our first law of reflection. Now we will see the second law. The second law is the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. So see here, the incident ray which is coming straight and the reflected ray which is going back, bouncing back in the same medium, and the point of incidence this and this normal all will lie on the same plane, all will lie in the screen itself. No rays will come out of the screen. That is called as all are in the same plane. Now the next one, question C. What is the focal length of a mirror? Very simple, focal length which is denoted by small f. So focal length of a mirror is the distance between the pole of the mirror and its principal focus. For example, if I take a concave mirror like this and if this is the principal axis, then what is this? This is a pole. The light rays when comes parallel to the principal axis, this is principal axis, I will label it x and y. The light ray which is coming parallel to the principal axis, see this arrow, it strikes the mirror and reflect back into the same medium like this and it goes. Another ray which is going parallel, it hits like this and goes back into the same medium like this. And after reflection, they will converge here at this point. This is called as focus, principal focus, which is denoted by capital F. And the distance between this principal focus and this pole, this is called as focal length. This whole distance, it is called as focal length, which is denoted by small f. And therefore, the definition is the focal length of a mirror is the distance between the pole, which is here, and the pole of the mirror and the principal focus which is here. So this whole distance it is called as focal length of a mirror. So this is the answer for question number 11. Now we'll see the next question. Now we'll see the OR question, which is again divided into A, B and C. We'll start with A. What is refraction of light? So see here we have to write the definition of refraction. Refraction of light is the bending of light when it passes from one medium to another medium due to change in its speed. This is called as refraction. So whenever light ray is passing, for example, this is the boundary. Imagine this is a rarer medium. You can take as air. I'll write it here in bracket, air. And this you can take as denser medium. Denser medium. So here I'll take as water. So this is rarer and this is denser medium and this is the boundary between the two medium. Now imagine the light ray strikes at this point. So once the light hit at this point, see here, and when it enters into the another medium, it get bent. It get bent like this. You can see the ray, the position or the way of the light, direction of the light changes. This is the incident ray and this is the refracted ray. See here, I'll write down what is this? This is incident. This is incident ray. And what about this? This is refracted ray. Refracted ray. And at this point, if I draw a perpendicular line like this, as I have drawn in case of reflection, then this is called as what? It is called as normal. I hope you are understanding. This is normal. So whenever the light travel from one medium to another medium, it changes its direction and that is due to change in the speed. Such phenomena is called as refraction. Now you can ask why it is changing the speed. Very simple. See here, it is rarer medium. Rarer means there will be much amount of space in between the particles. So this ray will get a high speed. Now, once it enters into the denser medium, dense, see here, dense means what? Thick. So, due to thickness in the medium, the light ray will get slow. And because of getting slow, it is moving or bending towards the normal. You can see here, it is bending towards the normal. And this phenomena is called as refraction. And if you reverse the medium, if this is denser and this is rarer, for example, if this is denser and if this is rarer, now what happens? And if the ray is coming like this, because it is dense, here the speed will be slow and once it enters into rare, the speed will increase and it bends away from the normal like this, because this is the normal and it is going away from the normal. So this process is called as refraction. now we will see the next question, that is B. State Snell's law of refraction. So here we have to write the Snell's law. You maybe have seen in your NCERT book there is one Snell, as it is also called as Snell's law. Like this one sentence is given. So that Snell's law we have to tell here. Snell's law of refraction states that for a given pair of media, see here, for a given pair of media, it may be a water or a glass, or it may be a air or a water, etc. So for a given pair of media, the ratio of the sine of angle of incidence to the sine of angle of refraction is constant. So remember, here also, in case of refraction, when the incident ray strikes on the incident point, it also makes an angle with the normal. So this angle, it is called as incident angle. And after bending, once the line enters into the another media, it bends. It may bend towards the normal like this when it is entering from rare to denser, or it may bend away from the normal like this when the light enters from denser to rarer. In both the cases, whatever angle it prepares after refraction between normal and refracted ray, this angle is called as refracted angle. So this angle is called as refracted angle. In case of reflection, it is reflected angle. In case of refraction, it is refracted angle. So these both the angles we have to use in Snell's law. So what does Snell's law says? Ratio of sine of angle of incidence to the sine of angle of refraction. So how it can be written? You can see here sine I, that is sine of angle of incidence, which is here, and sine R, which is sine of angle of refraction. We have to take the ratio. So sine I divided by sine R, and this value will be always constant. Remember, and but this will happen when for a given pair of media. So according to this only you have to write the sentence. If you write everything and if you didn't write this for a given pair of media, then the law will get wrong. So remember, you have to write. It states that for a given pair of media, the ratio of sine of angle of incidence to the sine of angle of refraction will be always constant, and it is denoted like this. This is the formula. So this is the answer for question B. Now the next is question C. Define the following with respect to lens. First is focal point and the second one is aperture. Focal point is nothing but principal focus. So we have to define what is principal focus, what is aperture, and that is in terms of lens. In case of lens, we have to define. So first we will start with focal point. The focal point of a lens is the point on the principal axis at which parallel rays of light converge or appear to diverge after refraction through a lens. See, very simple. Consider a lens like this. This is a convex lens, and if this is the principal axis, then this point is called as optical center. Now what happens? Whatever light rays will incident on the lens like this, those will get refract like this and bent on the other side. Then the next light rays will go like this and bent like this. So these rays, in case of convex lens, remember what is this lens? It is convex lens. In case of convex lens, the light rays which is going parallel to this principal axis. Now where is principal axis? This blue color is principal axis. See here. Now for this principal axis, both the light rays are parallel. Those will refract and they will converge here on this principal axis. So you can see here, after refraction, the rays will meet at one point, and such type of process is called as converge. This point is called as principal focus, or we can also call that is focal point. This is in case of convex lens. But what about concave lens? So let me draw it here. So if I use a concave lens like this, now see what happens. We will draw the principal axis. So this is the principal axis. I'll write X, I'll write Y, and the ray which is going parallel to this principal axis, see here, in case of concave lens, it will not converge, it will diverge like this. See here, ray will diverge like this. And after diverging, now where they're going to meet it? So what we're going to do? We are going to extend this diverge line on the same side of the lens like this. And we will try to join it here. So see, this is the point where they appear to diverge. and this point is called as principal focus, or we can also call it as focal point. So this is converge in case of convex lens, this is diverge in case of concave lens, and therefore the definition is like this. The focal point of a lens is the point on the principal axis at which parallel rays of light converge in case of convex lens or appear to diverge in case of, what is this, concave lens after refraction through a lens. So this point is called as principal focus or focal point. I hope you understood this definition. Now we are going to move with the next, that is aperture. The aperture of a lens is the effective diameter of a circular opening of a lens through which light passes. So here you can see, if this is the lens, then this is the effective surface from where the light is going to pass. So whatever effective surface, effective diameter or effective surface from where the light can pass, that surface or that diameter is called as aperture. So this is the aperture for convex lens, and for concave lens, if this is the area where the light is going to refract, then this is called as aperture of this concave lens. So I hope you understood the answer for this question, that is or option. Now we will see the next question. The next is question number 12. In this we have A and B. So we will start with A first. Observe the diagram of a below given electric circuit. This is the circuit which is given. Find the total resistance and total current of this circuit. So if you see the circuit, here we have three resistors, 12 ohm, 8 ohm, 16 ohm and 3 ohm. So these are the three resistors, and here we have a 9-volt battery. So voltage is 9 volt. We have three resistors, and the question is we have to find out total resistance for the whole circuit and total current. How to find out the total resistance of the circuit? First you have to see how these resistors are connected. Now you can see the first three resistance, 12, 8 and 16, these all are connected parallel to each other. Then what you have to do? We have to find out the effective resistance for these three by using parallel connection formula. And then whatever answer, whatever effective resistance we are going to get it here, that effective resistance and this 3 ohm, now these both are connected in series. And by using series combination formula, we have to find out the effective resistance for these two. Then whatever answer we will get, that is nothing but our total resistance. Once we get the total resistance, then we can use the total resistance to find out total current by using Ohm's law. So let's start solving. First we will write down what all given values, and then we will start solving. So here we will write first given. So what all values we have? We have 4 resistors. The resistors which are connected here in parallel, we will write it as R1, R2 and R3. So I'll write R1 12 ohm, then R2 I will write 8 ohm, then R3 I'll write 16 ohm, and these all are connected in parallel. So I'll write it here parallel. One more resistor we have, that I'll write R4, and for this I'll write 3 ohm, and these both have series combination. So I'll write it here series just for our information. Now leaving this, what we have? We have a voltage, that is capital V is equals to 9 volt. So these all values we have. First we will find out total resistance. So I'll write it here. First find total resistance. To find this total resistance, what we have to do, as I told, first we have to find out the effective resistance for these three which are in parallel, and then we have to find out for these two which are in series. So I'll write it here. The formula, that is RT, total resistance, is equals to what? RP, that is effective resistance in parallel, plus another resistance that I'll write RS, or I can write it as R4 because here I have labeled as R4. Now to find out RP, first we have to use the formula for parallel combination. So RP is equals to R1 1 divided by R2, then I have 1 divided by R3. So I have taken R1, R2, R3. So you can see the diagram. These R1, R2, R3 are connected in parallel. So these three I have used in this formula. Now substitute all the values. So I'll write it here. So sorry, here little bit of changes we have to do. That is, it is not RP, it is 1 by RP we should write. 1 by RP is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Make these all the correction in your notes also. So now we will substitute the values. 1 by RP is equals to 1 divided by 12 plus 1 divided by 8 plus 1 divided by 16. Now what you have to do? You have to take the LCM of these three. So find out the LCM of these three. And to find out the LCM, what I'll do? I'll find it out here itself. So I'll write 12, 8 and 16. So what prime number we can take? We can take the smallest 2 as prime number. 2 6 the 12, 2 4 the 8, 2 8 the 16. Then again 2 3 the 6, 2 2 the 4, 2 4 the 8. Now 2 1s are 2, 2 2s are 4, 3 will not come in 2 table, therefore 3 we will keep as it is. Now I'll take again 2, 2 1s are 2, 1 as it is, 3 as it is. Now I'll take 3. So 3 1s are 3, then 1 and then 1. So now I can find out LCM. LCM is equals to multiply these all the prime numbers 2 into 2 into 2 into 2. So we have to take 4 times. You can see here 1, 2, 3, 4 and now 3. So 3. So multiply this. 2 2s are 4, 2 2s are 4. So 4 into 4 into 3. Now multiply this 4 into 4, 4 4s are 16. 16 into 3, 16 into 3 will be 48. So therefore our LCM we got 48. Now substitute this LCM into our sum. So I'll write it here. 1 by RP is equals to, write down LCM 48. Now multiply this. Now you can see 12, how much is the 48? 12, 12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are. Then 8 how much is the? 8 6 are. And 16 how much are? 16 threes are. So now calculate. Here it will be 4 plus 6 plus 3. So 1 by RP is equals to what we are going to get? 6 plus 4 is 10, 10 plus 3 will be 13. It will be 13 divided by 48. Now it is 1 by RP. So reverse this, we will get the value of RP. RP is equals to, reverse this also, we will get 48 divided by 13 like this here. Now we will divide 48 by 13. So let me divide it on the side. So here I'll divide it. So I'll write 48. Here I'll write 13. So once we divide, what we're going to get? 13 threes are 39. Now see, so minus this, we will get 9. Here I'll get 0. I will take here 0. Here it will be decimal. 13 6 are, what we are going to get? 78. So I'll write it 78. 2. Then here I'm going to get 1. Another 0 I'll take. 13 9 are, it will be 1. 1 7. So what I'm going to get it here? 3. Here it is 0 and then 0 and it continues. So we will stop our calculation here. So I am going to get RP values as 3.69 and the unit is ohm. Remember, always we should write it units. So it is a resistance, so I should write it ohm. So here we got RP value. Now to find out total resistance, what we have to do, you can see this formula. We have to add this another resistance. This is the effective resistance for these three. So if you tell me to draw the diagram, it will be like this. Now see here, I am redrawing the structure. So now I got effective resistance of these three. It is 3.69. And to this there is another resistance which is connected, and that is of 3 ohm. And this whole thing is connected to the battery like this. This is here switch. Now you can see how it is looking. This effective resistance and this 3 ohm both are connected in series. Now if you use the series combination formula, we can easily find out the total resistance. And therefore, so now use the formula to calculate total resistance. RT is equals to, what is the formula? This is RP plus R4, or I can take RS. So I'll write both here so that you should not get confused. So RT is equals to, what is RP? We have got just now 3.69, and what is R4 or RS? It is 3. So therefore total we are going to get 6.69 ohm. This is the answer of total resistance. So we got the total resistance in the circuit. So here our first, that is find total resistance, is finished. Now we have to find out total current in the circuit. So I'll write it here. Find total current. Total current in circuit. So here we are going to use a simple Ohm's law formula, and the formula is, that is, V is equals to IR, and as we have to find out current, we will shift this R on the LHS side. So the formula will change. I is equals to V divided by R. Now substitute the values, that is I is equals to, what we have here, we have the values of V as well as R. So first we will write down the values. I question mark, V how much volt, 9 volt we have, and R just now we have calculated total resistance 6.69 ohm. So these are the values which I have to substitute here. So let me solve it on the another page because it will be little bit of lengthy because I have to show the calculations. So I'll write it once again here. So you should not get confused. Find total current in the circuit. So what is the formula? V is equals to IR. We are going to use Ohm's law. Rearrange it. I is equals to V divided by R. And the values what we have? V we have 9 volt. R we have, how much we have? 6.69 ohm. So substitute I is equals to 9 divided by 6.69. It will be difficult to divide it with this decimal. So decimal we will shift it on the two places, 1, 2. Here we are going to shift it on the RHS side. Once we shift it on the two-digit side twice, then on the numerator side we have to multiply with 100. Here we have to multiply with 100 because we are shifting this decimal on the second position on the RHS side. And then what I can get? I is equals to 9 into 100 divided by, now this you can write 669. And this will be how much? 900 divided by 669. Now this we have to divide, we will get our answer. So let me divide it here. Here I will write 900 and here 669. So first I will divide as 669. 1 the 669. So here I will get how much? 1, 3. Here I'll get 2. Then I'll take it 0 here. Then decimal. Then 669 3s are 2007. Then what I should write it here? 3. Then here it will be 0, 3, 0. Here I'll take one more 0. Then 669 4s are, I'll do. Here I will get 2676. What I'm going to get here? 4, 5. Then here I'll get 3. Here I'll get 0. I will keep one more 0. Then 669 5s are 3, 3, 4, 5. And here I'm going to get 5. Then 9. Here 1, 0. And you can continue this again. But here we will stop and we will write our answer. I is equals to, that is current is equals to 1.345, and the current unit is what? Ampere. So this is the answer for current. So total current is 1.345 ampere, and the total resistance is what we got? It is 6.69 ohm. This is the answer. So here we complete the question, that is from 12. Now we will see the next question on the next page. Now we'll see the B question. In the same question, that is the B sub question. An electric fan rated 50 watt is used for 6 hours in a day. What is the cost of the energy it consumes for 30 days at rupees 4 per 1 kilowatt hour. So you should read the question properly. See here, power is given, that is 50 watt, and we are using this fan 6 hours in a day. Then we are going to use this fan for total 30 days. The cost is 4 rupees per 1 kilowatt hour. So whatever cost is given, that is 4 rupees 1 kilowatt hour. So here it is in kilowatt hour, and whatever power is given, it is in 50 watt. So first we have to convert this power which is in watt into kilowatt, and then we can start solving this question. So let's write down first what all given values. So I'll write here given. So what all values we have? We have power. So power denoted by capital P, it is in 50 watt. But what I told, we have to divide it, we have to convert it into kilowatt, and therefore we will get here, I'll write 50 divided by 1000, 0 and 0 cancel, adjust this both the zeros into 5, so that we will get 0.05, and now the unit is kilowatt. So power is done. So what is the time? Time is 6 hours. So I'll write 6 hours. Then how many days we are going to use that fan? We are going to use it for 30 days. So I'll write 30 days. Cost of energy. What is the cost of energy given? Cost of energy. It is how much? It is rupees 4 per 1 kilowatt hour. See, this you have to write it very neatly. Now we will start finding the answer. First we will find energy consumed per day. So I'll write it here. Energy consumed per day. First find it for per day, and then we will find it for 30 days. So for this, the formula is power into time. So what is the power? Now we have converted 0.05 into what is the time? 6 hours. So write down this in a red color into 6, so that you will not get confused. And now when you multiply this, we are going to get 0.3 kilowatt hour. So this we got here, energy consumed per day. Now we have to find out energy consumed for 30 days. So here I'll write energy consumed for 30 days. You have to solve step by step so that you should not get wrong. If you go directly to solve, it will be very difficult. So now therefore the formula, what you have to do here, per day it is 0.3 and duration is 30. So I'll write it 0.3 into 30, and the answer is 9 kilowatt hour. So this is the value or the energy consumed for 30 days. And now the main question, that is cost of energy consumed. Now see what you have to do. For this, what you are going to do is, we know they have given rupees 4. This is the cost for per 1 kilowatt hour. 4 rupees for 1 kilowatt hour. Then what is our energy consumed for 30 days? 9 kilowatt hour. Then 9 kilowatt hour, how much will be the cost? See here, very simple. For 1 kilowatt hour, it takes 4 rupees. Then for 9 kilowatt hour, it takes how much rupees or the cost? So this we have to cross multiply like this. And once you cross multiply, so here we can get 9 into 4. And the answer is 36 rupees. Or I can write rupees 36. So this is the cost. So see the question. What is the cost of energy consumed for 30 days at this given rate? And this is the answer for the question. So I hope you will understand this answer, which I have solved in step by step properly, which I have explained very neatly. Write these all the answers in your notes so that it will help you to prepare at the time of exams. If you like my videos, share my videos with your friends, and please consider subscribing my channel if you are getting little bit also help from these all the videos. And if you have any doubts regarding these question papers, comment those doubts in the videos so that I'll solve those doubts and upload those videos. Thank you so much.